So since we've done some couple of examples and we've now understood what is expected of us and how to go about finding the remainder as well as the quotient. So now I'll give you some questions so that at least we can now indulge our creativity. So don't worry, there are not many questions. There are just few questions. So find the remainder and quotient of the following. So what is the first one that we have? We have 6x to the power 2 minus 7x plus 5. So divided by x minus 3. Then what is the second question that we have? We have 2x to the power 3 plus x squared plus 5x minus 4 divided by x minus 1. And lastly, but not the least, we have another polynomial which is 4x to the power 3 minus 3x squared plus x plus 2, which is divided by x plus 3. Okay, so these are the only questions that we have that I want you guys to try out. I'm sure you've seen the questions and you've written them down. Okay, so from this I'm going to wrap so that we can now look at something else. Just a bit to continue from this. Okay, perfect. So we are going to look at other examples. And these examples are saying that find the remainder of the polynomials, or find each of the remainders when the polynomials. So this is still examples. So find the remainders when the polynomials so these polynomials that we're talking about, we now have the first one, which is x to the power 3 plus 5x to the power 2 minus 17x minus 21 divided by x plus 1 and x minus 4. Then the second one, we have another polynomial which is x to the power 3 minus 2x squared plus 4x minus 3. So plus 4x minus 3 divided by x minus 3. Okay, perfect. So these are the questions that we have. So we now want to find this and solve them. How best can we find the remainder from the questions that we have on the board? So we're going to move to solutions. Since this time we don't want you to find the quotient, so from what we've been given here, the first question we've been given x to the power 3 plus 5x to the power 2 minus 17x minus 21, and this is divided by x plus 1. What does it tell us? What does it communicate to us? This simply means that we have this function which is f of x being equated to x to the power 3 plus 5x to the power 2 minus 17x minus 21. That is what we have. And it simply means that the value of this x, which is here, because we've been given x plus 1, it simply means that the value of this, when we equate it to 0, the value of x is now going to be negative 1, which makes our work easy, because given that the value of x is negative 1, all that we have to do is to substitute. So this is now going to be f of negative 1, which is equal to negative 1 raised to the power 3 plus 5 multiplied by negative 1 raised to the power 2 minus 17. This is supposed to have x. 17 multiplied by negative 1 minus 21. That is what we have. And having I've done this, this simply means this is negative 1 plus 5 plus 17 minus 21. And when we look at this, 17 plus 5, this is 22, and negative 1 minus 21, it is also minus 22, which is just going to give us 0. And from this, from the first part of the question, we can conclude that remainder is 0. Okay, fine. So since we've solved this one, we're also going to use the x minus 4 now. So from there, I'll write this part. The same function, but x minus 4, which simply means that x is equal to 4. So this will now be f of 4 being equal to 4 raised to the power 3 plus 5 multiplied by 4 raised to the power 2 minus 17 multiplied by 4 minus 21. And when we look at this, 4 raised to the power 3 simply gives us 64 plus 4 to the power 2, that is, what does it give us? That is 16. And 16 multiplied by 5, that is now going to give us 80. Then minus, what is 17 multiplied by 4? That will now give us 78 minus 21. So having I've done this, what will be the answer? When we look at this, this is, let's do it like this. So we have 80. 80 minus 72, it simply gives us a 2, right? And when we have that 2, which is a positive, 2 plus this will be 64. So 64 minus 21, which is now going to give us 55. So from here we can conclude that remainder is 55. Perfect. So we're now going to solve the last question which we have, which is this one. So I'll write this part since we've understood the first part. Okay, perfect. So here we have this, which is f of x being equal to x to the power 3 minus 2x to the power 2 plus 4x minus 3. And we've been told that x minus 3, that is what we've been given, which simply means that x is equal to 3. Perfect. So from here, it simply means that if we have f of 3, this will now be 3 raised to the power 3 minus 2 multiplied by 3 raised to the power 2 plus 4 multiplied by 3 minus 3. So if we have this and we expand it, this and this gives us 27 minus, this is 9, 9 times 2, which is minus 18, plus 12 minus 3. That is what we have. And this minus this, that is 9, than this will also give us a 9. That's also another quicker way of us getting the answer. So if we have such, it simply means that 9 plus 9, this is now going to be 18. And you can conclude that remainder is 18. And we are done. It's as simple as it looks. There is nothing complicated. So this is another way of us to find the remainder. So maybe we'll just try to add something small to this. So these were some of the examples. So what we are going to do is also the example. So we have that, and we are told that the polynomial, which is, so x to the power 3 plus ax to the power 2 minus 3x plus 4, that is what we have, is divided by x minus 2, and the remainder, so when this polynomial that we have is being divided by x minus 2, the remainder that we get is what? The remainder is 14. Okay. Find the value of a. So want to find the value of a, being given this question. So this simply means that if we have this function, which is f of x, being equal to x to the power 3 plus ax to the power 2 minus 3x plus 4, and then it's divided by x minus 2, which simply means that x is equal to 2, it's now going to be equal to 14. That's what we are talking about. So this basically means that if we have f of 2, which will now be 2 raised to the power 3 plus a multiplied by 2 to the power 3 minus 3 multiplied by 2 plus 4, this is equal to 14. That is what we're talking about. And what is 2 raised to the power 3? This is 8. 2 to the power, this is supposed to be to the power 2, sorry. So 2 to the power 2, that is 4. 4 multiplied by, so 4 multiplied by a, this gives us plus 4a minus 6 plus 4 equal to 14. That is what we have. So if we have such, what does it imply? Look at this. This is 8. 8 minus 6 gives us 2, right? 2 plus this 4, which we have on the other side, that gives us 6, right? So we're now going to have 4a being equal to 14 minus 6, which will give us 4a being equal to 8, right? Because that is 10 and the like, that will give us 8. Then over 4 both sides, and our a is going to be 2. And we can conclude that therefore a is equal to 2. Like, it is that simple. And we are done just like that. So maybe what if, again, we've been told that a certain polynomial is being divided by maybe more than 1. How best can we find these values like the one we found a? So this was perfect. So yeah, we'll wrap so that we can have more space to solve the second question. So let me wrap this. Okay. So if maybe we're saying that this is example 2, right? So if we are told that a polynomial, which is f of x being equal to x to the power 3 plus ax square plus, then you see now we have a lot of things adding up, plus bx minus 3. That is what we have. Then we are told that when this f of x, so when f of x is divided, so when this f of x is now divided by x minus 1 and x plus 1, the remainders are, so we have 1 and negative 1, 1 and negative 9. These are the remainders that we have. So we are now asked that find the value of A and B. That is what we've been asked to find, which is easy for us because this is not different from the previous example that we've done. So looking at this, what we've been given, we've been told that this function f of x, which is equal to x to the power 3 plus ax to the power 2 plus bx minus 3, when it is divided, it's being divided by x minus 1, which simply means that our x is equal to positive 1. This is equal to 1. That is what we are going to have as our remainder. Maybe let me write equal to r. But we know that this r is equal to 1. This is the first one that we've been given when it's being divided by that. So this simply means that we have f of 1, which is equal to 1 to the power 3 plus a1 to the power 2 plus b1 minus 3 equal to 1. Perfect. So this simply means that we have 1 plus a plus b minus 3 equal to 1, which simply gives us a plus b. When this one crosses, okay, this and this will give us negative 2. Negative 2 with this one, that is going to give us positive 3. So let us call this to be our first equation. Because the same function that we have here, it's now being divided by x plus 1. And remainder is negative 9. That's what we've been told. So this simply means that this is now going to be f of negative 1, because from here, the value of x is now going to be negative 1. It's going to be equal to, so we'll get the same function which we have here on top. So this will be negative 1 raised to the power 3 plus a negative 1 to the power 2 plus b multiplied by negative 1 minus 3 equal to negative 9. So this simply means that we will have, let me start from here. So here we're going to have negative 1 plus a minus b minus 3 equal to negative 9. And from here, this and this gives us negative 4. So we'll have a, okay, we're on the right track. So a minus b, which is now going to be equal to, this and this gives us negative 4, but when it crosses the equal sign, it's going to be positive, which will now make us to have negative 5. And we'll call this to be our second equation. So we're now going to solve the first equation and the second equation simultaneously. So if we say, so solving equation 1 and 2, so we have a plus b being equal to 3 and a minus b equal to negative 5. And when we solve at this, maybe let us try to eliminate A by subtracting, so that when we subtract this and this is going to give us 0, then we remain with 2b being equal to this minus negative 5. This will give us 8. Then b is equal to 4. So that is the value of b. Then let me wrap this side. Now that we found that the value of b is 4, we can pick any. We can even pick a plus b being equal to 3 when b is equal to 4. So this simply means that we have a plus 4 equal to 3, where a is now equal to negative 1, because 4 will cross the equal sign, which will be 3 minus 4, which will give us negative 1. And from here we can conclude that a is equal to negative 1 and b is equal to 4. And this question is as simple as that. And we found the value for for a and for b. So maybe we'll look at the last example under remainder theorem. Then we can see what can happen from there.